Welcome, and Han Yung, that was Korean for welcome, to this section on half angle formulas. And we'll do a number of problems. First one is, if cosine of A equals 1/2 with the angle A in quadrant 4, find sine A over 2. So I'm going to get the half angle formulas. So we have them available. I think I'm going to put them down here maybe. And sure looks like I need the equation editor. So sine A over 2, that's what we're supposed to figure out, equals, of course, plus minus square root of fraction 1 minus cosine A over 2 equals, now we're going to plug in the numbers. So here we're going to have 1/2, because that's what it says for cosine, so minus 1/2. Let's see, but what are we going to choose, plus or minus? Well, originally the angle is in quadrant 4, which means that the half angle A over 2 needs to be in quadrant 2. I discussed that in the lecture. The angle is between 270 and 360 degrees, so the half angle needs to be between 135 and 180 degrees, which is quadrant 2. So the angle for, so the sine here will turn out to be positive. And then we have 1/2 divided by 2 is a quarter, take the square root of that, and we come up with a nice 1/2, positive 1/2. There we go. Okay, next exercise says sine A equals -3/5 in quadrant 3. Figure out what cosine A over 2 is. Again, I'm going to use the equation editor. Scroll down a little bit so I have access to these identities. So this time around, we're supposed to figure out what cosine A over 2 is, which of course comes out to a square root of 1 plus cosine A over 2. We have this time that, oh, that's interesting. Let's see, I actually have to think because I don't have the sine A over 2 given in here, so what am I going to do with this one here? Well, we're in quadrant 3 with the sine A equals -3/5. That means that cosine, by the way, let's disregard this here for now. That means that cosine of A in the same quadrant, 3, also is negative, and it has to be -4/5. And that's what we'll be using. They always give us these nice numbers that we can do it in our head, the 3, 4, 5 triangle. Okay, so here now we can continue. Let's see. So it's going to be 1 plus -4/5. What do we have in front? Well, the original angle A is in quadrant 3, which is between 180 and 270 degrees. That means half the angle is going to be between 90 degrees and 180 degrees. So we're in quadrant 2, and that means, of course, for the cosine, we're going to have a negative. Let's see what we come up with. We have 1 minus 4/5 is 1/5, divided by 2 is 1/10. Take the square root, not much we can do, so it's going to be overall negative the square root of 1/10. Okay. So here I may want to add thus A over 2 in quadrant 2. And follow that cosine A equals -4/5. Okay, next problem says graph the following for x equals 0 to x equals 4 pi. On the graphing calculator. Let's go over there respectively. Let's look at what should we come up with. The cosine squared x over 2, that of course is an identity. So I take the left hand side here and I square the right hand side, which gets rid of the square root, which means this one should come out, and then it's being multiplied by 2. So this one here, what we should come up with is a cosine that is shifted up by 1. So imagine a cosine and just shift it up by 1 so that the troughs at the bottom of the cosine are just touching the x-axis. Let's see if that is indeed the case. Graphing calculator. Let's see, there it is. Okay. Y equals, so what we're supposed to graph is 2 times cosine x over 2, parentheses, square that. Before I do anything, actually I better check the mode. I'm in radians, so that's good. Go to Windows, and we're supposed to graph up to 4 pi. I needed to turn the microphone off for a moment, so I could cough without annoying anybody. This one here, I think I can leave the Y like this. And then I graph, and then there it is. And in comparison, I said if we use the half-angle formula, we should be coming up with this. 1 plus cosine of x. And we'll see if that one is correct. I'll make it a thick one. And indeed, that's the same one. And of course, I'll make a screenshot of that so I can insert that later. Whoops. There we go. Okay. Back to the lecture. So just like I said, this one here also looks the same as 1 plus cosine of x. Okay, next one. Find exact values for tangent 15 degrees. Pretty much looks like I need an equation editor here. So I'll be accessing that. Tangent 15 degrees, well, it's going to be tangent of a over 2. Again, at this point here, I may want to think about which one what I would like to use. I have 3 options. The first one, we actually tried that earlier, and we came up with this really complicated expression of square root of a square root. So I may want to try something else. I may, for example, use the third one. So we have 1 minus cosine A over sine A, and then we plug in the numbers, which of course makes, oops, what happened? Okay, which of course makes the angle to be 30 degrees. There we go. And there we go. So we have 1 minus the square root of 3 over 2, divide by 1/2, take the reciprocal of 1/2, multiply everything with 2. So we come up with 2 minus the square root of 3. There we go. Sine of 105 degrees. So we do the half-angle formula, plus minus square root of 1 minus cosine A divided by 2 equals, now we plug in the number, so 105 degrees is A over 2. Actually, I may want to write that down. Sine A over 2 equals. And now we plug in the number. So the degree is actually 210 degrees. 210 degrees. And with that one, sine of A over 2, we're going to be in the second quadrant, which makes the sign positive. So there we go. Cosine 210 degrees. The reference angle is 30 degrees. Cosine of 30 is square root of 3 over 2, which is actually negative. So we add it to it, and we actually do come up with a really tough one. And I just looked in the solution manual, and indeed that's what they have too. They have a complicated fraction here. So I'm going to use this one here. Oops. Plug that in there. And we have right here plus the square root of 3 over 2. As I said, it's going to be a minus negative for the cosine. Then I guess what we could do is we could take this 2 here, build both of them up, so multiply the denominator by 2 just to make it look a little nicer. So multiply the numerator as well by 2. There we go. And now what we can do is we can take the square root of 4 in the denominator, which means that gets rid of the square root in the denominator, and that's just cosmetics. So I'm going to do this one here, and we get rid of the total square root there. And as I said, it's not necessary, but it just makes it look nicer. Even that one is still square root within square root. Okay, a couple more problems where we prove these identities. So I'm going to take my half angle formulas along. Oh, was I supposed to check that with the graphing calculator as I wrote in my notes? Sure, let's do that. So I'm going to write myself a note here that we came up with tangent 15 degrees, supposedly 2 minus square root of 3, and sine the square root of 2 plus square root of 3 over 2. Go to the graphing calculator. All right, go out of here. Make sure that I'm in radian and degrees. I need to be in degrees. Okay. And tangent of 15 degrees, 0.26, 2 minus the square root, square root of 3, 0.26. So that's correct. And the other one was sine of 105 degrees. There we go. And the square root of 2 plus the square root of 3, parentheses, divide by 2, 0.96. I'm going to take a screenshot of that so I'll have it for later on and can paste it into the lecture document. Okay, prove these two identities. First one is 2 cosine squared theta over 2 equals sine squared divided by 1 minus cosine. Wow, that looks quite a thing here. I see that on the left-hand side. Oops, I need to do that. That on the left-hand side, I can use a half angle identity squared. So that means cosine squared theta over 2 is going to come out to 1 plus cosine over 2. So I'll do that. 2 times 1 plus cosine theta, yes we have, divide by 2. That 2 actually cancels with this 2 here. I'll do that in a moment. So what I just did here was a half angle formula. I'm going to scroll down here. Let's see what I'm going to do. Oh, the rest is very, very easy. Obviously, the 2's cancel. And then cross multiply. And then you might guess by now that we'll come up with the Pythagorean. So after the 2's cancel on the left, we have this here on the left. Then we multiply with this one here. Parentheses. And then, of course, on the right-hand side, we just have the sine squared theta after we had multiplied with the denominator. And so at this point, difference of squares yields the Pythagorean theorem. And we're done. I don't think I need to show this anymore because we had looked at this before. We have come across this particular one a few times. Okay, let's see what I'm going to do here on this one. I would say, of course, that on the left-hand side, as I have the tangent b over 2, I use a half angle formula. But at the same time, because I have this cosecant here, I may want to switch at least this one into something else like 1 over sine b. So I'm going to do that. 1 over sine b. And I may want to switch this one. Well, let's see. Let's do this one here next. Should be in a half angle identity. Which one should we have? Which one should we use? The first one, the second one, the third one. I would go with the third one simply because we have a minus on the right-hand side. Of course, we don't have a square root on the right-hand side. That's why I shouldn't use the first one. But the third one because it has that minus. So this one here is going to come out to 1 minus cosine over sine. So 1 minus cosine b over sine b. And now I may switch actually the cotangent here. I use the ratio identity, cosine over sine. Cosine over sine. And I can easily see that the left side already equals the right side. And we're done with this one. And what we did use on the left, the half angle identity. On the right, we use the reciprocal and ratio identities. And with that, I conclude the problem section for the half angle formulas.